around knowing our, now most of us don't run around, knowing our z-scores. So what do we do then? Let's go ahead and look at this example. This is some data I pulled off some statistical website, and it says the weights of newborn children in the United States vary according to the normal distribution, with mean of 7.5 pounds and standard deviation of 1.25 pounds. So the way we write this model is you write 7.5 pounds is the average deviation. So you might see this notation occasionally. You usually don't. The other way they would write it, and the way you tend to see it, is they would just write the mean with a symbol and then the standard deviation with a symbol. So the question is what is the probability that a newborn will weigh between 6 and 7 pounds? So first of all, I kind of got a head start on you. I went on the table and I said, oh, 7.5 pounds, that's the average. So that's right there. And if I go down one standard deviation, that's 6.25 pounds. Go down another one, that's 5 pounds. If I go up one, that's 8.75, and then another makes it 10 pounds. By the way, one of my kids actually did weigh 10 pounds at birth. So this section was ahead. 2.5% of the population weighs heavier than that kid. All right, so what is this z-score for a 6-pound newborn? So why am I asking for that? Well, a 6-pound newborn is going to be before 6.25. So that's where a 6-pound newborn is going to be. They're definitely way less than average. And the 7-pound newborn is going to be somewhere around here, 7 pounds. And this is 6 pounds. And we're asking what percentage, our goal here is what percentage lies there. Well, we're actually, all the work I've been doing when I did, say, the left-handed people back here, those numbers don't work for newborns. But what numbers work all the time? Using z-scores. So I'm going to change these to z-scores, and let's find out what the z-score is for a 6-pound baby. I'm going to guess it's between -1 and -2. So we'll go z equals, by the way, like memorize this, remember z, write it on your 3x5 card, equals x minus mu over sigma. You want to remember that. So the z-score for a 6-pound baby, it weighs 6 pounds, that's your x. The average is 7. And they told us the standard deviation is 1.25. And both of these are pounds on top and bottom, which means z-scores actually don't have units, which is a beautiful thing. Now I'm going to do to the hundredths place because most of our assignment today and the table, the yellow table we were looking at, goes to the hundredths place. So I did get -1.2, but I'm specifying -1.20. So what percent of babies weigh less than 6 pounds? So let me go ahead and draw this -1.2 here. Z equals -1.2. And so what percent is less than 6 pounds? It's that percentage, which I can get by looking up on a table, and negative, I'm on the negative side, -1.20. So that number is 0.1151. So it's 0.1151, and most of you like percentages, 11.51%. All right, so I know then that this is 11.51%, right here, the pink area. Now, what's the z-score for a 7-pound newborn? Well, I'm pretty sure it's between 0 and -1. So the z-score would be 7, pretend that's 0.5, there we go. 7 minus 7.5, because the average is 7.5, over 1.25. And that's pounds over pounds, which leaves out units, becomes unitless, -0.4. I'm going to go ahead and add the 0, because most of our work, we use z-scores to the hundredths place. So what percent of babies weigh less than 7 pounds? So I'm going to go ahead and draw this somewhere here. It's right about here. Z equals -0.4. And we're trying to find this percentage right here. Now, if I look up the percent of babies weigh less than -0.4 standard deviations, I'm going to get 0.3446. I stop here because it's -0.40. All right. So 0.3446 or 34.46%. Now, is that the yellow area? It's not. It's actually the pink and the yellow area. So this is equal to pink plus yellow. All right? What am I trying to find? Well, I'm trying to find the yellow area. What's between? So I can say that yellow equals, or I should say the probability that X is between 6 pounds and 7 pounds. Oops, pretend that's an X. Is the same as the probability for z-scores. So if I know the z-scores, it's between 0.20. Notice that one comes first. It's less than the z-score, negative 0.40. All right? Well, that's going to be this 34.46% minus the 11.51%, which is 22.95%. All right? So let's do another example. Here we have the mean score for the SAT is 1,500. Pretend that's 1,500. And the standard deviation is 240 points. And they want to know what percentage is between 1,600 and 1,800. Notice I didn't put Z there. That's the actual score. So that's your X. All right. So what do we do next? Well, if I can do this in z-scores, it's a lot easier. So here's 0, 1, 2, negative 1, negative 2, negative 3. The z-score for 1,600 equals 1,600 minus 1,500 divided by 240 equals 0.42. So that means it's almost halfway to 1. And that's right there. So 1,600. Z equals 0.42. Okay. The z-score for 1,800 equals the 1,800 minus 1,500 divided by 240. And this time we get 1.25. So it's roughly here. So what percentage falls into this area? Well, I can tell you that the pink area I know how to find from my table pretty easily because, let's see, 0.42, I got to be on the positive side, so I'm on the above average side. 0.42, 0.6628. See how I did the 0.4 and then I went to the 0.2. It's 0.6628, all right, or 66.28%. Pretend that's point. That percentage is the pink area. Now, if I do the z-score for this area, for the 1.25, that gives me both pink and yellow. So what's that percentage? 1.25 is definitely above average. 1.25, 1.2, all the way 0.8944. So this is 0.8944 or 89.44%. So the yellow area, probability that the z-score, is between 0.42 and 1.25. Remember, it was 1.25 here, which is saying that the x is between 1,600 and 1,800. It's basically going to be 89.44 minus 66.28%. which is going to work out to 23.16%. And next, there we go. Next we'll show you a shortcut.